The next presenter will be Sun Kai, who's the head of Smart Tracker Control Systems at TrinaTracker, and he will look into the details of digitalization and how that can boost the energy efficiency of a PV power plant. Sun Kai, the floor is yours.
Okay, let me adjust my computer. Okay, great. Hello, Michael. See you again.
Nice meeting you.
Okay, so is everything okay, right? So everybody can see my screen.
I just moved to presentation mode, please.
Okay, great. Okay.
Yep, all good.
Okay, good. Okay. Hello, everyone. I'm Sun Kai from TrinaTracker. I'm so glad to be here to talk about how digitalization boosts energy efficiency in PV power plants. Today, my presentation will include 5 parts. They are solar digitalization of solar power plant, TrinaSmart tracking solution, TrinaSmart control system, global application and case study, and its outlook and core values. Okay, so the first, let's begin with digitalization of solar power plant. PV technology has become a crucial clean energy solution. Digitalization and intelligent technologies are now the key to unlocking the future of solar energy. They provide comprehensive monitoring, maintenance, optimization, and management tools, enabling solar tracking systems to generate electricity more efficiently and collaborate with smart grids. This digitalized and intelligent technology drives the PV industry towards achieving carbon neutrality. In the field of solar tracker-based power stations, digital and intelligent technologies are extensively applied throughout the entire life cycle, enabling the creation of a truly smart energy source. This process can be summarized in 4 key stages. The first is design. At this stage, engineering methods such as finite element simulation are employed to simulate and analyze the structure. Structural analysis software assesses the strengths of the solar trackers. 3D modeling is utilized to create 3-dimensional tracker structure models with visual effects. Precise algorithm models are employed to optimize system performance. PV power generation simulation software is used to simulate and predict the electricity generation performance of the PV system. These measures ensure the precision and efficiency of the system design. The second is construction and installation. Utilizing building information modeling for digital architectural design and management to coordinate and optimize the construction process. Employing drones for visual inspection, monitoring, and surveying. Leveraging smart devices and machinery to enhance construction efficiency through automation and smart technologies. Conducting laser scanning for precise management and modeling. Implementing digital planning and coordinating to ensure adherence to construction schedules. Utilizing mobile applications for on-site management and communication, along with automated construction methods to enhance construction quality and efficiency. The third is commissioning. During the commissioning stage, the use of digital monitoring platform coupled with remote diagnostic tools is employed to identify and resolve potential issues. Last but not least, in the operation and maintenance stage, real-time monitoring and control are possible, allowing for immediate system adjustments. This operational status is visualized, enabling operators to intuitively understand the system's situation. Real-time monitoring of electricity generation data, including the recording and analysis of actual electricity generation, is conducted. IV curve and performance analysis tools are employed for the rapid identification and resolution of issues, accompanied by real-time fault alerts and fault localization analysis. Through equipment availability statistics, diagnostics, and root cause analysis, equipment failure are predicted and properly addressed. To summarize, these technologies enable PV power plants to achieve intelligent electricity generation, enhanced safety, smart monitoring, and intelligent maintenance, paving the way for a sustainable future in renewable energy. However, traditional tracking system currently faces several issues. For instance, under overcast or rainy weather conditions, these tracking systems continue to operate at conventional track angles, unable to fully capture solar diffuse irradiance, result in energy waste and a low efficient operation. In uneven terrain, modules located in low-lying areas are shaded by the front row modules, leading to a reduction in electricity generation. Additionally, in the case of a malfunction in the wind speed sensor, the tracking system will keep the trackers in a specific safe position until the sensor is repaired or replaced. During this period, the trackers, which should have followed the sun's movement, remain fixed tilt in a particular position, leading to a loss of solar irradiance and a subsequent decrease in power generation. Furthermore, the trackers control systems offer multiple power supply options for tracking systems equipped with lithium batteries. During continuous rainy days, the tracking system may enter a low battery mode. Two issues arise. Firstly, adjustments to other operating modes cannot be made in this stage. Secondly, when the weather turns to clear skies, it requires some time to recharge before returning to normal tracking mode, resulting in a certain amount of power generation loss. To address this issue, TrinaTracker has developed a smart tracking solution with a focus on high reliability, high performance, and high efficiency. The smart tracking solution includes various series trackers and a smart control system, including Vanguard 1P, which is designed for vertical single row and offers a slope adaptability of up to 20% in the north-south direction. The tracking range is -6 to 6 degrees. It is also compatible with cleaning robot solutions, making maintenance more convenient. Vanguard 2P designed for vertical single row and featured with multi-mode controller system and less mechanical components to further increase stability and reliability. It can support the installation of up to 120 modules with a slope adaptability of up to 15% in the north-south direction. In addition, TrinaTracker also offers Agile 1P, a dual-row linked tracker with a vertical installation of modules in one row, and a fixed origin, a kind of fixed tilt supporting structure. Besides these supporting structures, TrinaTracker attaches great importance to the digital technology-based software inference in the whole solution. Hence, smart control system is offered. And next, I will proceed to introduce the 3 products in TrinaSmart control system. First, let's have a look at the track controllers. TrinaSmart controllers provide various mainstream communication methods including wireless communication, LoRa and Zigbee, and wired communication IS-485. Multiple extreme weather protection strategies such as strong wind and heavy snow ensure the stable operation of the system. TrinaController provides various power supply options, including stream-powered, self-powered, and AC powered, to meet different requirements for different application scenarios. The unique dual power supply design enhances system reliability by incorporating the mainstream power supply and the backup battery. Next, let's have a look at the TrinaSmart Cloud. Last year, we have made further advancements in efficient operation and system security. TrinaSmart Cloud not only allows real-time monitoring and control of track operation, displaying operational data, but also introduces new features in operations. We are so excited to implement the 3D digital map functionality. 3D digital map provides an intuitive and vivid representation of track layout and operational status, enhancing the ability of maintenance personnel to carry out their work effectively. The mode diagnostic and pre-warning function assists maintenance personnel in identifying and eliminating risks before mode failure occurs, preventing damage and power generation losses. In terms of system security and stability, TrinaSmart Cloud now supports multi-role permission management. Power station owners can define access and operational permissions based on user roles, enabling precise management. Precise management. TrinaSmart Cloud support integrating with the Active Directory system, providing various account verification solutions for solar power station owners. The master-slave redundancy feature ensures high system uptime, while data sharing incorporates wind speed zoning functionality. TrinaSmart Cloud will further enhance intelligent management of data assets. What exactly is a 3D digital map like? And let's have a look. TrinaSmart Cloud will showcase the arrangement of trackers in 3D modeling based on their actual layout. The trackers are represented in different colors to indicate various operational status. In case of gray or yellow labeled trackers, maintenance personnel can swiftly identify and address abnormal trackers for accurate and rapid maintenance. SafeTrack is a highly intelligent tracking technology designed to boost the power generation and reduce power loss due to shading between adjacent arrays and in challenging weather conditions with high diffuse irradiance. It is adaptable to various complex terrains and comprises two core algorithms. The first is Smart Tracking Algorithm, STA, which leverages the patented bifacial irradiance model of Trina and improves generation power on a cloudy day or in other conditions with high diffuse irradiance. The other is Smart Backtracking Algorithm, SBA, which utilizes operational data for disturbance training, or in some cases uses terrain feature data to identify potential shading and then reduce generation loss due to roadway shading, which are more significant on complex terrains. SafeTrack integrates diverse data such as meteorological data, power generation data, and terrain data, etc., to fully explore optimization possibilities in different scenarios. SafeTrack operates efficiently and reliably through a combination of key mechanisms. Next, let's delve into SafeTrack's operational logic. The Smart Tracking Algorithm, STA, fully utilizes real-time weather information and historical meteorological data. On cloudy or overcast days, STA adapts to appropriate tracking mode to fully capture diffuse irradiance. As for how to cope with complex terrains, SupTrack provides two optimization methods. First, when it acquires terrain slope data or identifies terrain through drones, it generates a three-dimensional representation of the landscape. Using this 3D terrain model, SupTrack iteratively makes decisions to output the optimal group of backtracking angles to maximize the overall energy production. The second optimization method involves integrating inverter power generation data. SupTrack leverages real-time generation data, identifies each tracker's role shading status, and then sends a series of training commands to trackers. After training and based on the feedback data, SupTrack will analyze and determine the optimal tracking angles. After production, let's have a quick look at their global application and case studies. TrinaTracker's smart control system has achieved a remarkable performance globally since the first launch in May 2022, accumulating sales of 4.9 gigawatts across different regions. We believe that smart control system solution can contribute to the development of power plants through AI and digital technologies and further enhance the PV tracking system performance and efficiency. SupTrack has been validated and demonstrated in various projects around the world. For example, in Campina project in Spain, on typical overcast days, there was a gain of 5.55%, contributing to an overall gain of 1.16%. In the Huake project in China, on typical overcast and sunny days, the gains were 11.83% and 1.64% respectively. In the Shandong Technical Transformation project in China, on typical overcast day, there was a gain of 10.39%, resulting in overall gain of 2.3%. Finally, let's conclude with a brief summary and have an outlook of TrinaSmart Control System. TrinaSmart Control System is comprised with three parts, and they are track controllers, smart tracking algorithm SupTrack, and track level SCADA Smart Cloud. Trina controllers will focus on the current pain point issues in this industry and ensures stable communication, reliable power supply, and high quality battery performance. TrinaTracker will continuously enhance system robustness to meet diverse customer demands. On basis of what's being offered, SupTrack will focus on the research and do more research about sophisticated algorithms in more complex scenarios, such as south-north slope inference, seasonal variations. In short, SupTrack will be much smarter. Smart Cloud will further improve the system reliability and develop more advanced functions such as health diagnosis, 3D digital map, etc., to further enhance O&M efficiency. Okay, so that's all for my presentation, and thank you for your time.
Thanks, Sun-Kai. Very insightful. Just quick question. So the product, can this be also used for retrofits of your old products that are existing and the SunTrack, the SuperTrack?
Actually, so right now, for SupTrack, actually, SupTrack must be used together with Trina's controllers. Of course, for the smart control system, they can be used in a new project, and also they can be used for the technical transformation for the existing projects. So it's quite universal.
Okay, and you have this two SBA optimization methods and super tracks. Can you just talk about the different effectiveness once again?
Okay, so right now, for TrinaTracker, we offers two solutions for for the optimization on undulating terrains, right? So the first method is based on the terrain information. So I mean, if the terrain information can be provided by the clients, SuperTracker can directly use it and construct a 3D model and use other Trina's patented models such as mini shading model to calculate the optimal parameters and then do the input and upgrade the parameters. The second method is based on PV stream data. Suppose the clients they don't have the terrain data, so at this time we can use the second method. When SuperTrack acquires the PV stream data from the inverter, and then SuperTrack can do the analysis and will send a series of training commands to trackers. After the tracker give the feedback data, and the SuperTracker will analyze. For example, if this track row is shaded or not, if shaded, how to do the optimization, etc. So after the period of time for training, then SuperTracker will tell the tracker how to to move, to rotate, and then the whole trackers or the PV system can generate the most electricity. Yeah.
And maybe a final one. I think you had this 3D digital map that looked pretty cool, and then you have also digital maps. So what does it mean for your customers actually? Who can use what, and what's the difference here?
Yeah, because so 3D digital map is the latest function that we promote. So prior to that, we have offered the 2D digital map. I mean, 3D digital map is obviously more convenient and more friendly to the users. They can use 3D map just as I showed in the presentation. They can directly and visualize to see what happening to the trackers if the trackers has problems. And I think the 3D digital map would greatly improve their O&M efficiency. So right now, as long as the clients they purchase TrinaSmart Cloud and they can use 3D map, it's included in the in this product.
Okay, perfect. Okay, thanks a lot, Sun Kai. Great presentation.
Okay, thank you.